Okay, today we are going to use a scatter plot and create a trend line, a best fitting line. And from that, we are going to create a linear equation in slope-intercept form. So the first thing we're going to do is plot our points. So we have 150x, y 10. 250x, y 15, 325, which would be about right there, at 20, at 450, we're going to be at 30, and at 550, we're going to be at 35. Now, as you can see, these points don't line up exactly. However, they do show a trend. So now we're going to decide on the best fitting line for the points that we're given. So for instance, if I chose to go here, it's probably not quite the best fitting line because we have 3 points above and we are on 2 points. So we want to try to follow the trend the best that we can. And a lot of times you want to see if your points fairly are close, you want to have about the same amount of points above and below, and you want to follow that trend. So I'm thinking something about right in there looks fairly good. And every time you do this, it's going to be a little bit different anyway. But as you notice, we have one above, one below, and a couple of there look like they actually fall on the line. Also notice that I continued the line through the y-axis. The next step that we're going to do is determine the slope for this line. Now in the past we've used points to help us. Unfortunately, these points don't all fall on the same line. So we're going to use, for slope, we're going to use our rise over run. Now, we can do that a couple of different ways. We can go with our y-intercept and our x-intercept. But you notice they're fairly close. And we can give it a try. Notice we are at intervals of 5 here. So that would approximately be about -3. And we're at intervals of 50 here. That's going to be a little bit tougher to recognize. So you could say that is approximately 40. Maybe even 35. But if we did that, so our rise would be 3 and our run would be about 40. So that could be one of our, we might want to use that. A rise of 3, a run of 40. Another thing we can do is just choose points that are on the line. And so for instance, we have a great point right there. And we don't seem to have any other points that are crossing, but if you notice, it looks like our line is crossing right here at a nice little corner right there. So we could use 2 points that are on the line, especially if they intersect somewhere or somewhere that we can make a good evaluation or estimate of where they are. So if we started here at y at 15 and went up to here at y at 40, we have a run of, a rise, of 25. Then our run would be from here, we're at 250, we're up here at 250, from 250 to here is 600. So 600 minus 250 would be 350. If we put that in lowest terms, we would have 5/70ths. Well, just to kind of see how these two compare, we take 3 divided by 40, we get approximately, we actually do get 0.075, and 5 divided by 70, very close. So we can use either one of these. This one seems to be just as good as any. So now we're going to create our equation in slope-intercept form. So we have y equals our slope, 3 over 40, times x, and now we need our y-intercept. And so if we come down here to our y-intercept, intervals of 5, I believe we said it was 3 before, so we're at a -3, so we would be -3. And this is an example of a linear equation that we created with the best fit line.